Hello everyone, I am Uttam Khatri, pursuing my BTech from Lovely Professional University. Today we will be discussing about a very commonly used data structure, that is stack. We will be discussing how it works, its basic functions, and how it looks like in the memory. So let's start. So stack is a data structure used to store data in form of there is a no inbuilt data structure like it's a stack, and as we will be entering data into it, it will, let's say we enter the data a a then as we enter another data in it, it will be b. So data will be stored in such forms a, b, then c in levels. So it follows a simple principle of last in, first out. As we can observe from it also, let's say we entered c at last in our stack. So whenever we want something from this stack, then when we will perform pop function, and when we will pop something, then C will be the first to come out of the stack. So last in, C was the last to get in and was the first to get out. So this is the basic fundamental rule of stack data structure, last in, first out. Now as we want to enter data in stack, there are various functions like push. When we push data, it is stored in stack, and when we pop, it came out from the stack. So now we will learn the basic implementation of such functions with the help of Python. So let's start. So first of all, we will create a class named stack. It's not necessary to make the name to give it the name stack. It's just for our ease. So now we will be giving an constructor, sorry, that will be executed every time we call the class. So here we have created an empty stack named items. Let's make another function to check whether the stack that we are dealing with is empty or not. So return. So it's just a very basic line of code. It will return true if the length of stack named items is 0, or false if it has something in it. So next we will be defining a function that will help us to push elements in our stack. Then we will name it as push. We will take item as argument in it because of course we will be pushing something into the stack. So it should be taken as an argument in this function. So by this line of code, whenever we call the function push and enter some value in it as argument, that value will be appended in the stack names items. So now next let's deal with another function named push. Now we have done push. Now we will be doing pop. Else is the stack is not possible. So here we have done first, whenever you want to pop some elements, then first of all we will check if the stack is empty or not. If it is not empty, then it will simply return the uppermost item. And else if it is empty, so we don't have anything to pop, so it will display an index error. Like pop cannot be done from an empty stack. It is very obvious thing. So next we will be discussing the peep. So peak in basic English means a kind of peeking from top. So of course, whenever we will peek into the stack, as we have discussed, then it will show the uppermost that element of stack. So same here, we will first check if the stack is empty or not. If not, self dot item self is empty. If it is not empty, then return self dot items minus 1. So it is the uppermost index, uppermost element. Else, if it is empty, then again we will raise index error peak from an index. Sorry, there is some index. Peak from an empty text is not possible. Simply. So we can define various functions like this. Now we can define another function named define size. This will just simply give us the size of our stack. Return when self dot items. So as we have discussed our basic functions related to stack, now we will know I will be explaining or implementing them with the help of some examples. And it is showing some index error. Yeah. Now select stack. Now assign the class to some stack stack dot push one stack dot push stack dot push 3. So now in this stack we have pushed three elements. First of all we pushed 1, then 2, and then 3. Now we want to print the size of a stack. Stack size. We will call the function stack dot size. This will give us the size of stack. So let's run the. So stack size is 3 as we have pushed three elements in it. So let's check the uppermost element. Print top element stack dot peak. So the top element that we entered was 3. First of all, we entered 1 at the bottom, then 2 above it, then 3 above it. So 3 was the uppermost element that we entered. So whenever we will call the peak function, it will show us that element. So that was all in this video. Further, we will be discussing about various questions related to stack, which are commonly asked in interviews or in your college vivas. Very commonly, very common questions. We will be dealing with that. Thank you.